Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 7 from the October-November 2021 Mechanics paper 4 variant 2 from Cambridge 9709. I've already answered this question using one method, which is involving, resolving forces on the plane, finding the acceleration and using the Suvat equations. I'm also going to solve this question using the energy methods, which is the work energy principle. And hopefully, whichever way you prefer, you can choose. Sometimes they do specify in the question, use the energy method, or they specify a particular method. So you should be familiar with both methods of solving such a question. So it's important for you to understand both of them. And that's why I'm making a separate video explaining this other method, because they both are important to know. So it says, again, two particles A and B, masses 2 and 3 kilograms respectively, are connected by a light inextensible string. Particle B is on a smooth fixed plane, which is an angle of 18 degrees to horizontal. So there's no friction. Okay, we don't have to consider friction. So in terms of energy methods, that's going to cause us to have a change of approach slightly in our working. Okay. And this inclined at 10 degrees to the horizontal ground. The string passes over a fixed smooth pulley at the top of the plane. Particle A hangs vertically below the pulley and is 0.445 meters above the ground. The system is released from rest with the string taut. When A reaches the ground, the string breaks. Find the total distance traveled by B before coming to instantaneous rest. You may assume that B does not reach the pulley. So we have two situations that are going on here. You're going to have A falling down and B moving up. So there's going to be a change in their potential energies. And A and B both start from rest and they end up going at a certain speed, which will be the same speed because they're both connected with the light inextensible string. Okay, so it's a light string, tensions are the same. Inextensible means the velocity or the acceleration of the two particles have the same magnitude. Okay, so that's another thing to consider. So there's no friction, there's no other forces acting apart from, the components of the weight. Okay, so we don't have to worry about, work going in and work coming out. So basically, what we got to consider is the kinetic energy and the potential energy at the start of these systems. So I've got the drawing here again, so that we don't have to keep going, scrolling up and down. So basically, we're going to consider the kinetic energy at the start, which of course is 0. So I'm going to consider both particles. I'm going to consider what's happening to the kinetic energy of them at the start, plus the potential energy of them at the start. And I know that must be the same as the kinetic energy of both of them at the end, plus the kinetic energy of both of them at the end. Okay, so we're considering both their kinetic energies. Okay, so now, if we consider B and consider the fact that this is sloped, so we have a slope. We know the angle here is 18 degrees. So this angle is 18 degrees. Okay, and we know that A moves, so the start is for A is where it starts from here and ends there. For B, it starts from here and ends there. That distance is 0.45 meters. That's at the beginning. Okay, so what I'm going to try and do is work out what the speed of B is by the time it reaches this point here. Okay, and I'm going to use energy methods to do so. So I know that this height here, okay, I'll call that H, okay, is going to help us with the potential energy. This is for particle B. All right, so if we consider this distance here, this is going to be 0.45 times the sine of 18. It's opposite over hypotenuse. Okay, so this height is equal to 0. It's going to the sine of 18 is h over 0.45. So h is equal to 0.45 times sine 18. That's that vertical height. So at the start, the kinetic energy for both of them is 0, because they're both not moving. The potential energy for A, this is the start, this is the end. For this is the start, this is the end. For A, the potential energy is going to be mgh. Remember, potential energy is mgh, kinetic energy is a half mv squared. In this case, it's going to be the mass, which is 2, times g, which is, we'll call it g for now, times h, which is 0.45. That is the total potential energy of kinetic and potential energy of both of these at the start, when they start off their motion. And that must be equal to the total kinetic energy plus the total potential energy at the end. I should say potential energy, sorry. Okay, so the kinetic energy of B when it reaches this point, is going to be half times its mass, which is 3 times its velocity, which is v, which we have to find. That's what we need to know, the velocity with which it reaches this point, and then we can find the rest. And that is also, you're going to add to that the velocity of the particle A, which is a half times, that's times v squared, sorry, half mv squared. Half mv squared, sorry, half times 3 times v squared, plus a half times 2 times v squared. Okay, so that is the total kinetic energy of both of the particles at the end of this journey. And then we've got to add to that the potential energy of the system. So this has got to 0, but this has moved up. It's moved up. So you got m, which is going to be, in this case for B, it's going to be 3 times g times mg times h, which is 0.45 sine 18. That's mgh. That's the potential energy of the system at the end. This has potential energy of 0. Now there's no friction, there's no work out, there's no work in, no work out, nothing like that. So this is all the things that we need, and we have to find what V is from this. Okay, so we have 2 times g times 0.5. That's going to be 2 times 0.5 times g, that's times 10. That's going to be 20 times 0.5, which is going to be, I think, 9. We have 20 times 0.45, sorry, which gives us 9. And that's equal to 3 over 2 plus 1, that's 5 over 2, v squared, okay, plus 30, 3 times g times 0.45 sine 18. That should be 0.45. I almost made a silly mistake there. 3 times g times 0.45 sine 18. Okay, so we have to, that's 30 times, I'll just put this in my calculator and put the value down. In fact, I'll keep it in terms of sine 18. So 30 times 0.45, 30 times 0.45, 3g, yep, that gives us 27 over 2, which is 13.5 sine, g. Sine, yes, sine 18, 30.5 sine 18, that's right. Okay, that's 3 times 10 times 0.45, okay, sine 18. All right, so we want to find what v squared is. So we can do 9 minus 13.5 times sine 18, okay, and then we can basically divide by 5 and multiply this by 2. Okay, and that will give us the answer. So we take this, all right, and we just put in a calculator. Let's put it over this side. So we have 2 times 9 minus 13.5 sine 18. Second. Divided by 5. Okay, I think that's everything. So that gives me 1.9313. 1.9313. So this is v squared. So that means v, the velocity, when it reaches 0.45 meters up the plane, and when a reaches the bottom of the floor, the velocity of both of them is going to be the square root of 1.9313. Now we need to focus on the particle b as it now moves up the plane after it has reached 0.45. So it started from here, it's gone 0.45 meters up, okay, and it's reached the speed of the square root of 1.9313 meters per second. Now it's going to continue going up, but now it's going to come to rest at a certain distance, okay, which we don't know. I'll call it d, and it's going to reach 0 meters per second, okay. And if we consider the potential energy and kinetic energy, we got to consider the fact that it's going to reach a certain height above, vertically above where it started off this new section. Okay, so we're going to consider this vertical height. Okay, now I don't know what this distance that it's traveled is. That's what I've got to find, but we can work that out in terms of the height, because we know that the sine of 18 degrees is equal to opposite over hypotenuse, which is h over d. Okay, so the distance that it travels is going to be h over the sine of 18. So I can work out this height now using the potential energy, because now we can start, if we consider this the start and this the end, okay, so we can say that the kinetic energy at the start plus the potential energy at the start will equal the kinetic energy at the end plus the potential energy at the end. So at the start, it's going to be a half times m, which is 3 for particle b. I think it's 3. Yeah, 3 kilograms times v squared, which is 1.9313. That's the square root of v. Remember, this is the square root of v. And that's equal to the kinetic energy at the end, and plus the potential energy here, we're starting from this as 0. So it's going to be 0. And that's equal to the kinetic energy at the end, which is going to be 0 because it comes to rest, plus the potential energy at the end, which is m, which is 3 times g times h. So I'm going to find out what h is now using this. And once I found what h is, I can find what d is. Okay, so you're going to have h is equal to basically 3 times 1.9313, okay, over 6g. Okay, you're going to have to divide by 3 times g, the bottom there, so it'll be 6g. So that will be the value of h. Okay, so you'll have h is 3 times 1.9313 divided by 6 times 10. Okay, and what I'm going to find is d. So I'll write this down, 0.0965. 0.0965 continues on. So therefore d is going to be 0.0965 over the sine of 18 degrees. That gives us 0.31249. 0.31249. So therefore we can say, and I'll just keep it on this page, the total distance, okay, B travels is 0.45 plus 0.31249, which equals 2. So we take this value and we add it to 0.45. And that gives us 0.76249, 0.76249, continue on. So 0.762 meters, which is exactly the same answer that we got when we considered SUVAT. So this is answering the same question, question number 7, but by a slightly different method, by using or considering the energy methods. So we should be familiar with both ways of dealing with such questions, so that we can be able to answer any question that is posed to us. Okay, so that concludes this question from the October-November 2021 paper. Other questions from this paper, including the same question answered using SUVAT methods, can be found in the playlist that will be at the top of the screen at the end of the video. Other questions from the topic of work, energy, and power, you can find in the playlist over here. I'll also include inclined planes here, and you can subscribe to my channel by clicking on this link. So remember, if you do find, for example, that there is a playlist of mine for a paper and there's a question that you want me to answer that's not there, you can just simply send me a request on the channel and I will try to help as soon as I can. Okay, so that's something that you should keep in mind. Thank you for watching. I'll see you soon.